Hey, it's Lum again, and we're going to be doing some more electrochemistry stuff. And today we're going to be looking at balancing redox equations using half reactions. So last time we balanced half reactions in basic solution, and before that we balanced some half reactions in acidic solution. So now what we're going to do is we're going to balance a full reduction oxidation reaction. So what we're going to do is we have 4 steps right here. We're going to break our redox equation, which is this one right here. We're going to break it into 2 parts. Okay, and then what we're going to do is we're going to balance each half reaction, and then the whole goal is to get rid of the electrons. If you remember, when we had half reactions, we'd always have something like 2 electrons here to balance the charges. But what we're going to do is we're going to make sure that our electrons cancel out. Okay, and then we're going to add our 2 half reactions together to get our full balanced redox reaction. Okay, so let's get started. So here's our unbalanced redox reaction. And what we're going to do is we're going to break it up into 2 parts. Okay, so how you usually do it is you break it up by looking at your major species here. So we have uranium, U, right here, and UO2 over here. So I'm going to break that part up into 1/2. Okay, so I'm going to write U4 plus right here, and what it makes is UO2 2 plus. Okay, and then over here I'm going to do my other half reaction. So I have MnO4. Okay, and that's a minus charge on there, and that changes into Mn2 plus. Okay, so again, we're going to use that same thing, major hydroxide. So make sure our majors are balanced. Good, the majors are balanced. Now we're going to make sure that our oxygens are balanced. We have 2 oxygens here, so I'm going to add 2 oxygens over here. 2 H2O. Okay, and so now I have my oxygens are balanced, and now I'm going to balance my hydrogens on this side. I have 4 hydrogens, so I'm going to add another 4 hydrogens on this side. Okay, I'm going to take a look at my total charge. My total charge on this side is +4. My total charge on this side is +6. 4 times 1 is 4, and 2 is 6. So I'm going to add 2 electrons. So +2 electrons. Okay, I can give a quick check to make sure this is balanced correctly. Majors are balanced. Good. Okay, O, or oxygen, 2 oxygen, 2 oxygen, okay, balanced. H for hydrogen, 4 hydrogens, and our charge, 4 plus, and this is 2, 6 plus, minus 2, 4 plus. So everything is balanced on this side. Let's go to our other half reaction. We're going to balance this one. Same thing. Majors, already balanced for us. Mn is equal to Mn. Okay, and then what I'm going to do is I'm going to balance the oxygens. That's the next part. So we have 4 oxygens here, so I want to add 4 oxygens on this side. Okay, so we have 4 H2Os. So my oxygens are balanced. 4 on this side, 4 on this side. Now I want to balance my hydrogens. I have 8 hydrogens here, and so I need some hydrogens. So I'm going to put 8 on this side. Okay. Now finally let's balance our charge. We have 2 plus on this side, and this side we have 8 plus minus 1, so the total is +7 plus 2, so I need to bring this one down, and so I'm going to add 5 electrons. So plus 5 electrons. I know it's pretty tight, okay, but 5 electrons. Okay. So now this reaction, I have 2 electrons on the product side, and this reaction, I have 5 electrons on the reactant side. So what I'm going to do, so again, we've broken this up into 2, we've balanced these. I'm going to multiply it, each one, in order to eliminate the electrons, and then I'm going to add them back together. So I have 5 electrons on this side, 2 electrons on this side. Well, I'm going to have to multiply this reaction by 5, and this reaction by 2, and that'll give me 10 electrons on the products right here, and 10 electrons right here. So I'm going to times this by 5. Okay? So what I get is I get 10 H2O plus 5 U 4 pluses, and that makes 5 UO2 2 pluses and 20 H pluses. No, this is 20 H pluses, not 2 OH pluses. Okay, so 20 H pluses. And the most important part is 10 electrons. Okay, now I'm going to multiply this one by 2. And what I'm going to get is, let's give myself a little bit more room, multiplied by 2, so 2 times 5 electrons is 10 electrons. Oops, jeez, what am I doing here? 10 electrons plus 16 H plus 2 MnO4 minus and 2 Mn2 plus and 8 water. Okay, good. Now what I'm going to do is I'm going to add these together and cancel them out. Okay, so I'm going to take this here, I'm going to write it right underneath it, and then we're going to add it everything up together. Okay, so what I'm going to do is I'm going to write this one down here. So 5, make it a little better arrow, just pointed with my arrow quality. There we go. 5 UO2 2 plus and 20, again it's a 0 not a O, H pluses and 10 electrons. Now I gotta write this part up here, which is 5 U4 pluses and 10 water. Now I'm going to add these together, and we see some things start to cancel out. Okay, so let's start canceling these things out. Well, the most important thing is, and the whole point of it, is to cancel out these electrons. So these electrons are going to cancel out with these electrons. Okay, 16 H pluses cancels out with 4 of and 16 of these, which leaves 4. Okay, so I'm just going to write that kind of right there. And what else we got here? We have 8 waters cancels out with 8 of these waters, which leaves 2. Okay, anything else? No, that looks like pretty much it. And then we just add everything up and write it again. So, since our electrons and our H pluses canceled out, what we're left with is 2 MnO4s minus and 2 water and 5 U4 pluses. And what else we got here? Well, this water canceled out, so we're left with 2 Mn, 2 plus, and 5 UO2, 2 plus, and 4 hydrogens. Remember, 16 of these canceled with 16 of these, leaving 4 hydrogens left. Okay? And this is our balanced redox reaction. Hey, that was a pretty good box. Okay?